This is Brian Dolby reporting for ECOC TV at the Market Focus, where I'm talking to Steve Alleston of Ericsson. Steve, just given a very interesting session, 400G and beyond. Tell us a bit more about that.
Well, I mean, we're at an interesting point in this industry where we're in the process of rolling out some very high bandwidth services in a response to increasing demands from our customers for not only more bandwidth but more manageable ways of doing that. And we've developed a very interesting toolbox of techniques to do this, but now we're faced with the challenge of going to the next step, which is 400 gigabit or even 1 terabit per second transmission. And really the sort of toolbox we have today isn't quite up to the job, so we're having to go beyond and develop even more advanced techniques to make this a reality.
Where are we at the moment?
Well, at the moment this year we've seen the first deployments of 100 gigabits per second in a number of different markets using a technology called coherent, which is a way of improving the OSNR and extracting more information from the signal to allow you to do more compensation from that. And that's been a long time coming, and it uses some very advanced silicon technologies based on 40 nanometer CMOS and digital signal processing. And it's really with a step beyond that and the implication on the network that I was talking about this afternoon.
What are the main challenges?
Well, the main challenge is whenever you go up in bit rate is that the actual optical bandwidth you require to transmit that efficiently increases. And we're at the point now where we've kept the same bandwidth, 50 gigahertz, all the way from 2.5 gigabit up to 100 gigabit. But that isn't going to work at 400 gigabit and beyond. So that means that we're going to have to change the way we do filtering in the network, and we're going to have to do something we call adaptive modulation on flex grid filtering. So rather than having fixed filters, we're going to be changing the way we do the filtering and the modulation almost on the fly to make sure that we retain the spectral efficiency of the network whilst having usable transmission distances. And that's really the main sort of challenge in front of us now, how to manage that whole flexible setup.
And is that really what the industry is looking at now? How's the industry coping with this requirement?
Well, there's a lot of developments underway in a lot of key areas to make this happen. Not only in control planes and in the filtering itself, but we're seeing really significant advances in things like photonic integration, the ability to take multiple optical elements and integrate them onto a single substrate, using some very basic processing techniques. CMOS processing for photonics is something that's a very hot topic of research, and that's going to have a very strong bearing on some of these applications going forward. But also in the fields of DSPs, great leaps are being made in terms of improving forward error correction using soft decision instead of hard decision, increasing the speed and reducing the gate size from 40 nanometers to 28 and 22 nanometers. And when you combine all these things together, you start to get a feeling and you start to get a roadmap to where, say in 3 or 4 years, this is actually going to be a viable ecosystem and we're going to be able to build and deploy these products for our customers.
Because we need it, don't we? We're reaching capacity probably quicker than a lot of people realise.
Yes, I think that's certainly true. I mean, the surprising thing that I think has taken most people by surprise is how fast video has accelerated. The success of Netflix is, of course, extremely common, and that's something that is just going to continue. So no one is now asking what is the killer app driving more bandwidth. It is where am I getting my bandwidth from? That certainly is not a debate anymore.
Okay, well, Steve, thanks very much for talking to us.
Thank you very much.